Hi Ninja Nerds! In this video we're going to be talking about the rule of nines and the Parkland formula. If you like this video, give it a thumbs up, comment down below, don't forget to subscribe. Also check out ninjanerd.org where we have our video, lecture notes, and illustrations available for you. And don't forget we have Twitter, Instagram, and Facebook where you can check out other stuff as well. Let's get into this. When we talk about the rule of nines, what we're talking about here is the percent of the total body surface area that is burned, or it's also abbreviated the TBSA. So rule of nines is essentially a bunch of nines, or percentages of nines, that equal the 100% of the body area and the body surface area. And what we're doing is we're looking to see how much of the body surface area has been burned. And why are we doing this? We're doing this because when a patient does unfortunately have some type of significant burn to their skin, they're going to have some problems with fluids and fluid shifting. And when that does happen, you have a chance of hypovolemic shock. So first, let's just talk about the rule of nines, and I'm just going to run you through it really quickly. So the rule of nines basically is going with an adult. So a normal size adult, average size adult. It's not going to be the same percentages for an obese patient because their trunk, they have more soft tissue, they have more surface area within the belly, so they're going to have a different percentage there, which can throw off these numbers. And also pediatrics, their head, if you ever looked at a kid or a baby, their head's really big compared to the rest of their body, so their percentages are also going to be different and their head is going to be a bigger area. But for this video, we're going to talk about the rule of nines, and we're going to talk about the different percentages and how you can remember them for tests. The way I do it, and in my head, if you like this version, great, then it's something you learned and it's a little easier for you. If not, I'm going to go through the traditional as well. But for me, I always think of the rule of nines. It already tells me like nines. So in my head, I'm already picturing nines and multiplications of 9. And I always picture like a person holding 2 nines. So I got my little stick man here. And these are just the totals for the posterior and the anterior numbers. So I do 2 hands, or 2 arms, basically. They're both holding 9s. The head is 9. The body, or the trunk, this whole area is the biggest part of the body. So it gets our biggest derivative, which is 36. And then each leg is 18. And then in the perineum, I draw it between the legs. I draw a 1. You know why I draw a 1, because that's what it looks like. So that's how I can remember all of the rule of nines and the derivative of nines. And then from there, when I get into test questions or anything, I'm able to put it in half or put it into anterior, posterior, top and bottom, things like that. But for those of you who are like, Kristen, you're going so fast, rules of nines, what the heck are you talking about? Again, we're talking about the total body surface area that's burned. And we can go through the traditional here of the anterior and posterior. So anterior head, so just the front, basically the face, the head and the neck, is a 4.5, right? That is half of 9. And then half for posterior is also 4.5. Then we have our arms, right? We have a total for the right arm and a total for the left arm. So we have a 4.5 here and a 4.5 here, 4.5, because we're cutting this in half for our anterior and posterior. Then for our trunk, we have a total of 36. So if we cut that in half, anterior and posteriorly, it's 18 and 18. Or you can even cut these in half more and say superior trunk, or the chest area, and then inferior trunk. Those can be even broken into 9 and 9, 9 and 9. Then we go into our anterior. Anterior is the only part where the perineum is, and that's our 1, so we just put our 1. And then we have our totals for our legs. Total for this leg is 9 and 9, and total for this one is anterior and posterior 9 and 9. So I'm not sure if that helps you more or confuses you more. For me, in my brain, I like just to do the total stick man, but if you want to do anterior and posterior, it's all about what works for you and what you use consistently. So just keep that in mind. If you like doing both of these, great. If you like doing the stick man, that's also great. So for me, when I get to a test, I like to just jot down this little stick man here, draw in or write in the totals, and then I can go on and proceed with the question. So we're gonna actually do a practice problem right here for just the rule of nines. And it says, a patient has burns to the anterior left arm, anterior chest, and left leg. Calculate the total body surface area burned. So this is my systematic approach to how I solve these problems. I just go through one at a time and I write down either underneath or to the right of it, what I am looking for. So it says the patient has burns to the anterior left arm. So I say anterior left arm. Then it says anterior chest. And then it says left leg. So left leg. So a couple things to dissect here, right? We have anterior left arm. So this is talking about only the front of the left arm. So we're looking up here. You could say it's 9, and then you're going to cut that in half, which is 4.5. Or if you have your figures drawn like this, we know that the front of one arm is 4.5%. Then we have anterior chest, right? So this is talking about the front of the trunk, right? And in the NCLEX, what they like to do is they like to use words. It doesn't say trunk here, right? It doesn't say anterior trunk. It says anterior chest. So we know that the front of the chest, or the anterior, is 18. But when we're talking about only the chest, or the superficial part of the trunk, we're going to cut that 18 in half. So now we only have 9%. And the last is left leg. We know the percentage for the left leg here is 18%. It doesn't say anterior or posterior in the problem. It doesn't say any of that. Just says left leg. So it's going to be 18%. Then we're going to go through and add these all together. I just plug it in as it's right there, 4.5, 9, and 18. And we get a total of 31.5%. Okay, so our total body surface area is 31.5%. Let's move on to the Parkland-Burn formula. The Parkland-Burn formula, what are we using this for? What is the purpose of this? Again, we have a patient that's unfortunately been burned, and we are trying to figure out the total fluid replacement in 24 hours. So from the time of that burn, that 24-hour ticker is starting, and we want to figure out our bodies and our patient's total body surface area that's been burned. We need to know their current weight, and then we're going to multiply it by 4 milliliters. And what that does is that gives us our total crystalloid replacement. Now, in the NCLEX and as well as in practice, there are two things to understand. Once we have that 24-hour fluid replacement that we know the amount the patient needs, it's broken into 2 doses. We have the first 8 hours where they get half of that milliliter, and then half of that milliliter volume that they need, and the next 16, they get the other half. So it's important to know that, because on the NCLEX, they will ask you certain questions about the Parkland-Burn formula and your patient, and they're going to say, what are they going to get in that 16-hour total, that second half or something like that. And you need to understand, I have to break this up in half, and I know that the first half goes to the 18 and the second goes in the 16 hours. And we know that 8 plus 16 equals 24, and that's our total 24-hour replacement. So remember, it's the first 24 hours from the time of injury, and we're going to practice a problem right here. So we have a client or a patient that weighs 79 kilograms, and remember, we're always using kilograms, and it has a total body surface area of 36%. So we're just going to write this down. We have 79 kilograms, right? We have a total body surface area of 36%. And we know that it needs to be 4 milliliters, right? These are our numbers. If you're like me, I don't like seeing it like that, so I like to write 4 times 79 times 36, and then we plug that in. 4 times 79 times 36, and that will equal 11,376 milliliters. And that will be our total fluid replacement for this patient. So I have 4 other problems that we're going to be using the rule of 9s and the Parkland-Burn formula together, going through and practicing these, because I don't want you to feel stressed about these. And I think if you walk through these with me and get that repetition, you're going to be able to get these questions right on the NCLEX. So let's get some practice problems in here. Let's read through number 1, and I'll just show you how we go through them. What you want to do is you kind of want to create a repetition so that when you are doing these problems and you see them on your tests or on your NCLEX, you're going to be able to say, hey, I know how to do this, because it's going to be muscle memory. So the first one says, an RN is caring for a patient with full thickness burns of both legs. The patient's admission weight is 192 pounds. We want to calculate the 24-hour IV fluid replacement. So in your head, you're already thinking, all right, I got to use the Parkland burn formula. So let's go through. The patient has full thickness burns on both legs. So first, I would draw my little stick man. And I always picture this stick man. It's like maracas in their hands. So we remember it's 9, 9, 9 for the head. The trunk is the biggest percentage, which is 36. 18, 18 for both legs because they're bigger than our arms, and then 1 for the perineum. So now the patient that I'm caring for has full thickness burns on both legs. So it just says both legs. So we know right leg, left leg. Doesn't say anything about posterior, anterior. Doesn't say anything about top, bottom, anterior, inferior. So we know that the right leg is 18%. And the left leg is 18%. And these are full thickness burns. Remember, it doesn't say anything about them just being superficial, because superficial don't count, or anything that is greater than superficial, like partial, superficial partial, or superficial deep. So our patient has full thickness burns on both legs, our right and our left leg. We know that that's 18 and 18, which is our 36%. Then it says the patient's admission weight is 192 pounds. We know that being a ninja nerd, that 1 kilogram is equal to 2.2 pounds, right? So when we cross out our pounds, we're left with kilograms. So what we have to do is take 192 to divide it by 2.2, and we get 87.3 kilograms. Okay. So now all we have to do is multiply 36 times 87.3 times 4. And we're going to get 12,571.2 milliliters. Awesome. Now remember, depending on what the question is asking for, it may even say round to the nearest whole number. It may ask you a couple other things. So just keep in mind, we're reading the end of that problem and we're giving them what they want, and they're asking us just for the total IV fluid replacement of 24 hours, and this is our answer. Let's move on to the next one. A 40-year-old female patient has deep partial thickness burns on her posterior trunk, front of the right leg, anterior head and neck, and the perineum. The patient weighs 160 pounds. Calculate the total lactated ringers that the patient will be given in the next 24 hours. So let's first draw our little man. Little stick figure here. And then I like to do my maracas. 36, 18, 18, and 1. Okay, so female patient has deep partial thickness burns on the posterior trunk. So post trunk. Front of the right leg. So anterior right leg. Front of the right leg, anterior head and neck, and perineum. So we have anterior head, neck, and perineum. So the patient has partial thickness burns on the posterior trunk. Posterior trunk is half of 36, which we know is going to be 18%. Front of the right leg. So the right leg, the total is 18. We need to do only the front or the anterior, so it's going to be 9%. Anterior head and neck. We know that the head fully is 9%, so half of that, or anterior, is 4.5%. And we know the perineum is 1%. So let's make sure we got it all. Patient has partial thickness burns posterior, front of the right leg, anterior head and neck, and the perineum. So now we're going to add all this up. So we got 18 plus 9 plus 4.5, enter plus 1. And we got 32.5. Now we have a patient that is 160 pounds. So what do we need to do with that? You should already be thinking. Going to divide by 2.2 pounds to get my kilograms, which is 160 divided by 2.2. is 72.7 kilograms. Now we can plug this in to find out how much of our lactate ringers we're going to be getting. So 32.5 times 72.7 times 4. All right, 32.5 times 72.7 times 4. Enter. And we get 9,451 milliliters. Okay, and we want to make sure, calculate the total lactating ringers that will be given in the next 24 hours. So we have a total there, and we're good to go. Let's move on to the next part. Let's move on to number 3. Number 3 is asking us a patient weighs 150 pounds and has superficial deep burns on 50% of their body. Calculate the expected amount of fluid that the patient should receive by 2200 when the burns occurred at 1400. So the first thing we can do is just say, hey, thanks for giving us the TBSA. We know that the TBSA is 50%, so we don't even got to calculate that right now. Now we know that the patient weighs 150 pounds, and we have to convert that to what? That's right, kilograms. So we're going to take 150, divide that by 2.2, and we get 68.18. So 68.2 kilograms. Now it's telling us to calculate the expected fluid that the patient should receive by. So let's look at that really quickly. We know that 1400 and 2200 are the times. Now 1400 is 2 p.m. out of military time, and 2200 is 10 p.m. out of military time, and we know that that is an 8-hour lapse. Awesome. So now let's calculate our total fluids and then figure out what they should have received by 10 p.m. So we have 68.2 times 50 times 4, right? So using the Parkland burn formula, we know that we multiply by 4. And we get 13,640 milliliters. But it's asking us, calculate the expected fluid that the patient should have received by. And we know we've already had an 8-hour lapse. So what does that mean? That means we should be giving them half of their fluid. So we're just going to divide that by 2, and we get 6,820 milliliters. And that is our answer. Okay, so you want to be weary of those last lines in problems because they like to throw little zingers in there like this one. It wasn't asking us for the complete amount. It's asking us for what they got in their first 8 hours. And you being an engine nerd know that the first 8 hours is half of the fluid because the next 16 is the other half, and that's our 24-hour fluid replacement. Let's move on here to number 4, the last one. And you know it's going to be a doozy, so let's go. A 69-year-old male has full thickness burns on both of the legs, on the back, front of the trunk, both arms, front and back, and the perineum, and front and back of the head and neck. The patient weighs 206 pounds. You have already infused the first 8 hours. What will you set the flow rate on the pump to complete the 24-hour fluid replacement? So let's break this down even further. Let's go through our list. Actually, let's draw our stick man. You're probably like, wait, no, stick man. I love stick man. All right, so we got maracas. They're holding maracas. They're holding 9 in the head, 36 in the torso, 18, 18, and 1. Okay, now let's go through. They have burns on both of the legs on the back. So posterior right leg, posterior left leg. Then they have front and back of the trunk. So posterior and anterior trunk. Then they have both arms front and back. So we got posterior, anterior, right arm. Posterior and anterior left arm. Perineum. and front and back of the head and neck. Posterior and anterior head / neck. And you're probably thinking at this point, where is the patient not burned? Like what is left that's not burned? All right, let's go through and add these on. So we know posterior right leg means half of the total. So that's going to be 9%. Posterior left leg is also 9%. Posterior and anterior trunk means the entire trunk, so 36%. Posterior and anterior right arm means the entire arm, that's 9%. Posterior and anterior left arm means the total arm, again a 9%. Perineum, 1%. And posterior and anterior head and neck, also 9%. Okay, so let's add all those up. So we got 36 plus 1 plus right leg, left leg, arm, and head and neck. We got 82%. 82% of this patient is burnt. All right, now we also are asked that the patient weighs 206 pounds, and we know that 206 pounds divided by 2.2 pounds is equal to what? We got to convert that to kilograms. So we get 93.6 kilograms. Okay, we got our percent and we got our weight, and now we're going to figure out the fluid replacement total. So 93.6, let me write it, 93.6 kilograms times our 82% times our 4. And we get 30,708 milliliters. Now remember, you're not supposed to round until you get to the end. So right now, we have the 30,700.8 milliliters. We're not at the end of our problem. So let's keep going. It says you have already infused the first 8 hours. So that should be telling you what? You should be dividing this in half. So we know that 8 hours was 15,350.4 milliliters, and the next 16 hours will be that other half, right? And it says, what will you set the flow rate on the pump to complete the 24-hour fluid replacement? So they already got the 8 hours, so that's gone, and now we got to give them over the next 16 hours this 15,000. So we're going to take that number, divide it by 16, and when we do that, we get 959.4 milliliters per hour. Now, some pumps will let you plug that in, some pumps won't. And depending on what the problem's asking you, if it says to the nearest whole, then you can round this to the nearest whole, which would be what? It's a 0.4, so you just put 959 milliliters per hour. Okay, so remember, why are we doing all this? We're doing all this because we have that intervascular fluid shift, and all this fluid starts shifting out of our intervascular, and we can become hypovolemic. So because of all that shift, we need to make sure that we're giving our patient adequate fluid back. And what we're doing is we're trying to make sure that we're not fluid overloading them, so they're getting any type of pulmonary edema, and we're not giving them too little fluid where their kidneys are going into failure. So we want to make sure that we're giving our patient, and it's per patient, that's why we need that weight to give them that adequate fluid back. I hope this made sense. I hope you learned something. And as always, until next time, Ninja Nerds.